Hello everyone. Today I'm going to talk about IPv6 addressing techniques, specifically link local, multicast, and anycast addressing. These techniques play a crucial role in IPv6 communication, replacing and improving upon IPv4's traditional addressing methods. So before we dive into the specific addressing types, let's quickly understand why IPv6 was introduced. The internet was running out of IPv4 addresses due to its 32-bit limitation, so IPv6 was developed, offering a much larger 128-bit address space. IPv6 differs from IPv4 in several ways. It eliminates the need for broadcast by using multicast. It has built-in security with IPsec, and it simplifies the header structure for faster processing. IPv6 addresses are categorized into three main types: unicast, multicast, and anycast. So let's talk about the link local addresses. These are automatically assigned to every IPv6 enabled device and are only valid within a local network segment. All link local addresses begin with the prefix that's given over here and are not routable beyond the local network. This means they're only useful for communication between devices on the same link. These addresses are essential for tasks like neighbor discovery protocol and router communication, ensuring that devices are communicating even without a manually configured address or a DHCP server. So link local addresses are assigned automatically when a network interface is enabled. The system either generates an address using the EUI64 method or uses randomization. To identify different interfaces, IPv6 appends a zone index to the address, such as the one shown over here, which specifies the interface used for communication. So for example, two laptops connected with an Ethernet cable can communicate using their link local addresses, even if no router or external network is available. Next, we have multicast addresses. These addresses are used for one-to-many communication, replacing IPv4's broadcast function, which was inefficient and created unnecessary traffic. Multicast addresses always begin with the prefix shown over here and can have different scopes like link local or global. They are commonly used for routing updates and the IPv6 neighbor discovery protocol. Some important multicast addresses are shown over here. The first one, which targets all nodes on the link. The second one, which is used for communication with all routers. In the third example, it's known as the solicited node multicast. It is used in the neighbor discovery protocol. And the fourth one here is used for multicast DNS. So for example, when a router needs to send an update to all connected devices, it can use the second prefix over here so to address each router in the local network. Now let's discuss anycast addresses. Unlike multicast, which delivers data to multiple devices, anycast is designed for one-to-nearest communication. An anycast address is assigned to multiple devices, but the network directs traffic to the nearest one based on routing distance. This is particularly useful for services like content delivery networks and DNS resolution. So for example, Google Public DNS uses the anycast address shown over here, meaning your request is automatically directed to the nearest available Google DNS server. So how Anycast works. Anycast works by advertising the same IP address from multiple locations. Routers then determine which server is closest and direct the request accordingly. For example, if a user is in India and another in the United States, both request a web page from an anycasted IP. They will be directed to the nearest data center, improving response time and load balancing. Let's summarize the key differences between the IPv6 addressing techniques. Link local is for communication within a single network segment, like between a PC and a router. Multicast allows one device to send data to multiple devices simultaneously, useful for network discovery and updates. Anycast directs requests to the nearest server, making it useful for CDNs and DNS services. Each of these techniques play an important role in modern networking, improving efficiency, scalability, and security. So this graph over here sums up the different categories of IPv6 addresses and the addresses that we use to access each of them. So in conclusion, IPv6 introduces significant improvements over IPv4, and its addressing techniques enhance network performance. Link local ensures devices can communicate without extra configuration. Multicast replaces inefficient broadcast traffic, and Anycast optimizes global service delivery by directing users to the closest server. As IPv6 adoption continues to grow, understanding these concepts will be essential for networking professionals. Thank you for your time. I hope this presentation helped clarify these important IPv6 techniques.